Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Okay, in the last session, I share with you what is the correlation. Yeah, correlation give the numerical value on the strength of the relationship between the two variables. We call it independent and dependent variable. Whereas linear regression is simply a formulation of mathematical expression between the independent and dependent variables. Okay. So next, okay, for this particular chapter, we are going to cover 6 subsections. Like I mentioned in the last class, I will cover 5.1 up to 5.4. Okay. Okay. An example, what is correlation? Yeah, this is in a study, the relationship between the number of hours students spend studying for an examination and the marks they obtain are investigated. Okay, so this is a real data, yeah, that I record from one of my class in the previous semesters. Okay, let's say I have students A up to H, yeah, 2, 4, 8, 6 students. Sorry, 8 students. Okay, so there are numbers of hours students study. Yes, student A 5 hours, and the final marks he or she got is 49. Yeah. Similarly with B, he studied 8 hours and then scored 60. So in this case, you want to see the relationship. Is there any relationship between these two variables? Yeah, number of hours and final marks. So X will be the independent variable and Y, the final marks will be the dependent variable. Okay. Now, we can see that from this, data, yeah, as the numbers of hours spent is more, so has the final marks will be better. Okay. So generally we can see, before we do any further analysis, using regression, okay, we can just scan through the data. You can see that the final marks may depend on the number of hours students spend studying for an examination. Okay. Okay, other example, on the regression, examples of regression. For example, the weight at the end of the spring and the length of the spring. Yeah, so you can see that maybe this is what you did during your school days, where you have a spring, and then you put the weight at the end of it. So you put different weight of weight, and you want to see the length of the spring, how much it extends. So this is an example. You want to see the weight and the length of the spring. Okay. Temperature and pressure. Okay, so for example, as we go up the hill, what happened to the pressure? So when the temperature is decreasing, what happened to the pressure? So we want to see child's age and height. Does it mean that taller child, has the child go older, is the height increasing? So we want to see that relationship. Similarly, a student's mark in a computer test and also mark in mathematics. Is there any relation between the two marks? Okay, and the last example is the diameter of the stem of a plant, and the average length of the leaf. Does it mean that if the stem is wider, does it mean that the length of the plant leaf is also lengthier? So we want to see to see the relationship between the two variables. Okay, scatter diagram. This is a diagram that we use to represent the relationship between the independent and dependent variable. Normally on the x-axis, on the horizontal axis, we denote the independent variable, and on the y-axis we denote the dependent variable, which is y. So from the plot, we can see the trend of the relationship. If it is going up, as one variable is, let's say x is going is increasing, so has the y increasing. That means we have a positive linear trend. Whereas if the other way around, if the value of x is increasing, yeah, x increase, y decrease, that means we have a negative linear relationship. Yeah. So the first case is x increase, y also increase. That means we have positive relationship, yeah, positive trend. If the other way around, we have negative trend. Okay. So that is an example. Okay. And another example is whenever we have this kind of relationship, yeah, it is not linear, but you can see that it's like a curvy linear trend, yeah. So the formula will be different, yeah, as compared to the linear regression. Okay. And the last one is when there is no trend, yeah, you can see that the value of x, yeah, and y, yeah, it increase and decrease without any pattern, particular pattern, yeah, no particular pattern, yeah, or trend. Okay, so that means no pattern, yeah, that means no relationship, yeah. Between the variables. Okay, between the independent and dependent. So there is no significant relationship between x and y. Okay, so that is the use of scatter plot. Okay, we can simply draw a scatter plot using the Excel, using the Excel. Okay, correlation coefficient. Okay, now I mentioned in the first session, correlation coefficient is simply the numerical value that give the strength of the relationship. Okay, so this value is being introduced by Carl Pearson in 1900. Yeah, and the notation we use is R or rho for population correlation, and for sample we use small r. Okay. So it is used to indicate the linear degree, yeah, of the scatter plot or the strength of the relationship between the independent and dependent variable. And also it gives the direction, yeah, either positive or negative. Yeah, positive mean when x increase, y also increase. That is positive trend, yeah, direction. But if the other way around, yeah, x increase, y decrease, so the direction is negative. Yeah. Okay, the value of r is between -1 and 1. So it cannot be more than 1. Okay, it is independent of the units of scale of variables. So it is dimensionless. Yeah. So no unit for correlation coefficient. R has no unit. So the correlation coefficient is not robust. It is easily affected by outliers. Therefore, we should always check the scatter plot with R value. Yeah. So we need to be careful when we have outliers data. Okay. So we always need to double check with the plot. Yeah. So that is what it means. Yeah. So you cannot simply look at the numerical value of R and then make a conclusion. You also need to check on the scatter plot. Then, yeah. So the nearer the value of R to 1 or to -1, that means the closer the points on the scatter plot are to the regression line. So whenever we draw, okay, so if all the point is on the line, that means R equal to 1, yeah, or the other way around. If all the point is on the straight line, so R equal to -1, yeah. So the closer the point on the scatter plot, that means plot R to the regression line. Yeah, so that is what it means when R equal to 1 or -1, close to. Okay, we can calculate numerically the value of correlation coefficient using this formula. Yeah, S sub xy divided by square root of sxx square root times square root of syy, where sxx stand for the sum of xi, yeah, x sub I squared minus the sum of xi all squared divided by n. Yeah, similarly for sxy, syy. Okay, so these formula are given in the statistical table. Yeah, so you can refer this. Yeah. Okay, this is the table on how we interpret, yeah, the value of R that we have calculated. Yeah, So if R equal to -1, for example, it is perfectly negatively correlation. Yeah, there are perfect negatively correlation, yeah, between the variables. So for example, that I draw just now, that is when we have this relationship. Yeah, all the points falls on the straight line, but in a negative relationship. Okay, so if it is between -1 to -0.7, yeah, strong negative correlation. Okay, and so on. Yeah, so between -0.7 to -0.5, it's moderate, and less than that will be weak negative correlation. If R equal to 0, yeah, so that is what we have just now when we have this no relationship just now. Yeah, so this is an example of R equal to 0. Yeah, no relationship, no specific trend between X and Y, direction of X and Y. Okay, similarly on the positive side, if it is less than 0.5, that means weak. Between 0.5 to 0.7, it is moderate, and more than that will be strong positive. Yeah, so it is R equal to 1, then it is perfectly on the positive trend, and every point is on the straight line. Yeah, perfect positive. So this is R equal to 1. Okay, so you can always refer to this table in order to interpret the correlation coefficient that you have. Okay, now using this data from table 1, okay, the example that I give you just now, we can draw the scatter plot. Yeah, this is using Excel. Yeah, so you can see that, yeah, has value of X increase, so has the value of Y. Yeah, the number of hours increase, the more students spend on preparing for the final exam, the better marks they will get. Yeah, so you can see that there is a positive trend there. Yeah, so this is just observation, yeah, from the plot of the data. Okay, and this is how we use the formula. This is just an example. We don't expect you to show this calculation using during your quiz or test. Yeah, you'll spend a lot of time. Actually, in using calculator, you can easily find this value. Yeah, you can find this value, yeah, automatically. Yeah, by keying in your value. Okay, for example, the correlation coefficient that we calculate, yeah, using this data, yeah, using this data, y and x, and we find xxy, sxx, and syy, and substitute into the formula, you got r equal to 0.9448. So how do we interpret? So from the tables just now, this value is more than 0.7. So it shows a strong positive linear correlation between x and y. In other words, there is a strong positive linear correlation or relationship between the number of hours students spend to study and their final marks. Yeah. So we can say that those who spend more time will obtain better results. Okay. Okay, and make sure you practice using calculator. So this is the steps on how to use your calculator to key in the value so that you can get this value automatically. Yeah. So this is important. Yeah. So you need to practice this. Okay. So see you next time.